Okay, welcome to Module 13 of Network Security Fundamentals series, where we will be discussing incident preparation, response, and investigation. Hopefully, by the end of this video, you will learn how to explain the steps in preparing for a cybersecurity incident, describe how to respond in an incident, and list the steps in an incident investigation. There are many reasons for a cybersecurity incident to happen, right? So in the first part, we actually want to touch point on some of the reasons that you may be dealing with a cybersecurity incident to begin with. They can be classified into two broad areas. Those who happen based on you having a weak account type, and the other are based on you having poor access control. So when a malicious actor can exploit your vulnerabilities, usually you can drop the consequences and the actions in one of these categories, right? So usually the strong authentications should be required for all the user accounts, because if they're not in there, we're opening ourselves to the possibility of the account being compromised and turning into the first foothold for the bad actor. Also, the accounts should be routinely reviewed for security and actually for the mere existence reasons. You may have an employee who is kicked out of the company and nobody remembered to actually change the account, or a mistake happened, nobody deleted or disabled their accounts, and now it's a long time that they actually have access without even being employed. So there are many reasons to that, but generally, we have to have routine reviews of the user accounts and the security privileges of each account, especially when the accounts are for the internal employees that move between the departments, and their privileges must be changed, or the role changes and the privileges must be changed. We really are in need of the routine review of the accounts. So we should not allow anybody to share account, meaning people should not be sharing passwords. We should not allow to have generic accounts, like let's say the sales department have a sales account named sales123 or something like that, that is just generic. And the guest account should be disabled for sure, because its guest account doesn't need a password and can be compromised easier than any other type of account. Other factor is the poor access control, right? The access control itself is granting or denying approval to use a specific resources in a network or a computer itself. We do have the physical access controls. We already have discussed those before, something like fencing, hardware door locks, man traps, badge readers, and all of those. And we also have the technical access controls, which consist of the technologies that restrict the user's access on computers or network devices when it comes to accessing information or services. There are standard access control models that are being used, and in the coming slides, we're going to go through those. But before we start talking about the models, let's talk about the concepts that come to the access control. And here we want to talk about quadruple A, which is, consists of identification, which we need to recognize and distinguish the user from any other user, right? We need to authenticate them, which is performed by checking the credentials against the database and making sure it's authentic. And then authorization, which is granting permission to take a specific action or having access to the specific resource. And when this access is granted, it's basically the right given to accessing specific resources in different levels, which we're going to talk about it. Like you're going to have a user that can only see the resource. You're going to have another user that can modify, change it, somebody else that can actually change the access levels to that specific resource. And then finally, accounting is the record that is preserved of who accessed the network, what they did, where they went, when they disconnected, and all of those. So Basically, identification, authentication, authorization, and accounting are what make your access control concepts valid and valuable. You have to go through all those steps when it comes to access control. There are some other terminologies that we need to learn when it comes to how computer systems impose technical access control. One is the object. So any specific resource is called an object, like a printer, like a file, like a service. Then the other one is the subject, which is the user or the client that actually wants to gain access to a resource. When we talk about user and clients, it also includes the applications, the code. So let's say if you have an application that is accessing a database in order to read some information and represent a report, that also is a user of the database or a client of a database. So still is called a subject, right? So operation is the other terminology, which is the action taken by the subject over a specific object. So basically, subject operates the object. That's how you can remember this. Let's take a look at this one to understand the jargon a little bit better. So in this case, we have a subject here. He's an end user, right? The operation that the subject wants to conduct on the object, which is the salary Excel file. You see this Excel file is the object, and the subject end user wants to conduct an operation in there, right? When that needs to happen, we need to do the IEEE, go through identification, authentication, authorization, and accounting at the end, right? When this specific subject is providing the information about themselves, right, which is the identification, then different subjects are going to have different levels of access. For example, if the subject is the owner, they can actually do whatever they want with this resource. Other subjects are limited by the owner into certain levels of access depending on what they really need to do with the object and what is their role in the company. Role-based access control, which we're going to talk about very soon, is one of the most commonly used access control models to define the interactions between subjects and objects and the level of the operation that can actually happen. So this access control schemes are standards that provide predefined framework for hardware or software developers. We use the appropriate scheme to configure the necessary level of control, and that's a part of privileged access management process. There are 5 access control schemes, which are the major ones and most commonly used ones in the industry and the local networks. So first and foremost, discretionary access control or DAC, mandatory access control or MAC, role-based access control or RBAC, or rule-based access control, which sometimes we call it RBRBAC, and then attribute-based access control or ABAC. And let's dive deep into every single one of those and understand how they are, what they do, and how they are actually working. First one, discretionary access control scheme, is the least restrictive. It's really open because every object has an owner who has total control over their own objects. So let's say if you generate a file within a network, you are the person who has full control, and other owners as well have full control over their own objects. Owners can give permissions to other subjects over their objects, or they can deny permission, right? This scheme is used on major operating systems, right? Like Windows and Mac and all that. DAC has 2 significant weaknesses. First of all, it poses a risk in that it relies on decision by the end user to set the proper level of security, and basically you're at the mercy of the knowledge and security understanding of your users when you're using DAC. And the other one is the subject's permission will be inherited by any program that the subjects executes. And if that permission is not set according to the best practices of cybersecurity, then you actually are opening up towards any possible attack and towards any possible abuse. So at the best, you are at the mercy of the level of security understanding that the data owners and employees are bringing to the table. Then we do have the most restrictive access control model, which is called mandatory access control, or MAC, in which the user has no freedom to set any controls or distribute access to other objects. There are two key elements to MAC, one labels and the other one levels. So every entity is an object and is assigned a classification label that represents the relative importance of the object. Like classification label could be confidential, could be restricted, could be public, internal, and such. And then you have levels, which are a hierarchy based on the labels that then we use those, right? So there are different levels that the labels fall under. So MAC grants permission by matching object labels with the subject label. So if the subject has the confidential label and the object has the confidential label, now the object can access the subject. Or if the object has lower confidentiality label in comparison with subject's confidential label, then still the use can happen, but it's not going to work in the reverse, right? So the labels assigned to objects and subjects indicate the level of privilege. So the higher the level of privilege of the subject, the more resources in the network they can access. Microsoft Windows uses a MAC implementation that they call it the Mandatory Integrity Control, or MIC, which we will be discussing later down in this series. So then we do have another model, which is called RBAC, or role-based access control, which is also called non-discretionary access control. Access permissions are based on the user's job function. And this model serves very well when it comes to enterprises that they have different departments and therefore they have different groups, right? RBAC assigns permissions to particular roles in an organization, and the users are going to be assigned those roles so that as soon as they have the role, they can actually have access. Objects are set to be a certain type to which subject with the particular role have access. Think about a company that has a sales department and a service department, right? And then you have the service database and you have the sales database. So technically what they do is they create a group called service personnel, and they grant access to the service database to this group. And then any user that is being hired as a service personnel just simply gets added as a member to this group, and then the access is automatically granted. And same for the sales database and the sales group, right? But think about a technician that decides, okay, I don't want to stay in service anymore. I want to go to sales and try to sell some, right? And the only thing administrator needs to do is to drag them out of service group and just drop them into the sales group. As soon as this happens, their access to the service server or service database automatically is being revoked because they're not a member of service department anymore, but the access to the sales database is automatically being granted since they just got added to the group on the sales department side. Next one that we have is the rule-based access control, which is also called rule-based role-based access control, or RBAC. This one brings in the dynamic assignment of roles to the subjects based on a set of rules defined by a custodian. Each resource object contains access properties based on those rules. When a user attempts access, the system checks the object's roles to determine access permission. So not only the role, but the rules are actually applied. That's more intelligence, that can be more manageable, and you can do more granular access control. For a lot of entities, this really is not needed because of their mission and the business requirements. But if the business requirements are requiring such fine and granular access, then this can be used. RBR back often is used for managing user access to one or more systems. Business changes may trigger applications of the rules specifying access that change, and therefore the access control for the user change as well. We also have the ABAC, or attribute-based access control, which uses more flexible policies than rule-based access control. And basically what it can do is it can combine different attributes, and then policies can take advantage of attributes such as object attributes, subject attributes, and environmental attributes. And ABAC can be formatted using an if then else structure. So basically, for an example is a user can have access to certain database only if a certain condition is met. So let's say this user can access the sales database only if they're using company's portal to access the database. But if the user wants to directly access database through their computers, through any other application besides the application that company approves, then the access is not granted, right? Or it can be a timed access. User have access to the accounts between 8 a.m. and 9 p.m. only if the account has a negative balance, right? So as you can see, you can come up with different type of if then else conditions, and you can even make them nested and make them more complicated so that you can have even finer and more granular control over the accesses. The access control lists or ACLs are a set of permission attached to a certain object. An ACL specifies which subjects may access to the object and what operations they can perform. When a subject requests to perform an operation on an object, the system checks the ACL for an approved entry. They want to make sure you can do what you want to do. And ACLs are usually viewed in relation to the operating system files, folders, and resources. ACLs provide file system permissions for protecting files managed by the operating system, and also being reported to be useful in desktop operating systems that normal users use. I have a screenshot here from my Mac. If you look at this, as you can see, we do have a list here of the users. In this case, this resource has two users. One is a simple users, which is myself, and then a group of users, which is everyone is listed here. And as you can see, respectively, we do have a privilege level. Like I can read and write to this resource and everyone has no access. So any other user on the computer that I'm on, and for your information, this is a Mac screenshot, not a Windows screenshot. That's Windows is showing the same thing, but in a different format. But all in all, at the end of the time, you have the users and you have the level of access they have. ACLs have also been ported to SQL and relational database systems, or RDBMSs, so that ACLs can provide database security as well. There are some limitations that they come with ACLs. First of all, is using the ACLs is not efficient because you have to go to each resource and manually enter the access controls list for those resources. And the ACLs can be difficult to manage in an enterprise setting where many users need to have different levels of access to many different resources, such as adding, deleting, changing ACLs on individual files and all that. At the end of the day, not only these are time consuming, but because those are dispersed around the enterprise, they are prone for the mistakes to happen and therefore the bad posture for the security. So no matter which one of these models is being used, as you can see, every single model has their own weaknesses, and every single one has some possibilities of being exploited by a malicious actor, especially if the malicious actor knows what to do. And in that case, an incident is going to happen. So the whole idea is, okay, now that we have a system that is vulnerable, no matter what we do, and and we're going to talk about the frameworks of vulnerability very soon. We're going to talk about Meyer or Diamond and all of those models. But for now, what you should focus on is, okay, there is vulnerabilities that are being revealed day by day, like zero vulnerabilities, which enable the attackers to exploit the system. When they exploit the system, an incident happens. Now is the time for incident management or incident response, right? So to prepare for an incident that is inevitable to happen, we create an incident response plan. An incident response plan, or IRP, is a set of written instructions for reacting to a security incident, and it includes 6 action steps to be taken when an incident occurs. So preparation, which is the initial step, identification, containment, eradication, recovery, and then finally gathering the lesson learned. At a minimum, an IRP should contain documented incident definitions, right? So everybody is on the same page on how to speak about those and how to look into those. Incident response teams. The teams must be clearly identified and the roles associated with those teams. Who's going to do what in case of an incident? Reporting requirements and escalations. Okay, what needs to be reported? To whom needs to be reported? When do we escalate this to the higher levels in the hierarchy of the company or enterprise? Then the retention policy, for how long we're going to keep the information, for how long we're going to keep these reports. The stakeholder management, different roles and different benefits that different stakeholders have from the plan. And finally, the communication plan. How the communication happens. Is this going to happen over Teams chat? Is it going to happen over email? Is the communication going to be encrypted? Is it not going to be encrypted? How fast it's going to happen? Somebody's going to call somebody, and so on and so forth, right? So there are a lot of corners that needs to be shaped on the incident response plan before you actually put it into the action. When the plan is put together, you need to test the plan, and there are multiple ways of testing the plan. You can either do a tabletop exercise, which on a monthly basis, people gather, the stakeholders or major stakeholders gather, and they discuss different aspects of the plan and hypothetically try to find the efficiency and make sure it is working. This is going to be in a stress-free environment. There's not going to be an actual or simulated incident or anything. Then it can be tested by walkthrough, so which is a review by IT personnel, and they look at the steps of the plan. They pay particular attention for the IT systems and services that may be targeted in an attack, and they're going to evaluate how the plan is going to react and how the plan is going to be effective against possible attack against those resources. And then finally, simulation is a hands-on simulation exercise which uses a realistic scenario to thoroughly test each step of the plan. So basically, an attack is going to be simulated, the impact is going to happen, and then the IRP is going to be followed to see how effective the IRP is going to be. So all of these can be done under known frameworks, right? The frameworks are the resources that help model thinking and actions of a bad actor. There are 3 common attack frameworks, including Meyer attack, Diamond model of intrusion analysis, and cyber kill chain. So Meyer attack is basically, you can go to their website, it's meyer.org, and on the website, you're going to have access to different lists of vulnerabilities, different steps of an attack, what are the certain characteristics of an attack, right? And the Diamond model of intrusion, as you can see here, we are looking at 4 corners. So we study the adversary, infrastructure, capabilities, and the target. And through these 4 corners, We can study the possibilities, the steps that they can actually take in order to compromise a system and how to react to those systems. But one of the most comprehensively looking into the matter comes from the cyber kill chain, right? So for cyber kill chain, defines the 7 steps that a bad actor is going to take in order to compromise your system, starting from reconnaissance, going to weaponization of the attack based on the information gathered in the reconnaissance, then the delivery of the weaponized tool, which can be, let's say, a Trojan within a phishing email or anything like that. Then the exploitation happens, which is when a vulnerability is being exploited by the threat, and then possibly installing the malwares on the asset or installing the agents on the asset, and then command and control. So then they basically take control of the asset, either as a foothold or as the final target, and they do what they need to do through the last step, which is actions on objectives. So whichever model is being used is gonna help understanding the attacker better, the process of attack better, and therefore coming up with the plans to mitigate their actions or stand against them. We have a knowledge check activity here. The question is, in which type of access control can access policies be based on the properties of the objects, subjects, and the environment, and can be constructed using if then else statement? The correct answer is attribute-based access control. If you haven't responded correctly, go back and watch the video from 5 minutes back, and you're going to find where we discussed that. So, steps that should be taken when responding to an incident are, first of all, taking advantage of your SOAR. There are runbooks and playbooks that come with your SOAR that can be taken advantage of. Perform the containment, making sure the attack is contained, and then making configuration changes to respond to the attack and stop the attack from being able to penetrate deeper. A security orchestration, automation, and response, or SOAR product, which we discussed in Module 1 and 2, can help security teams manage and respond to security warnings and alarms. A SOAR allows a security team to automate incident response. We do have playbooks and runbooks coming out of the box with your SOAR, right? A playbook is a linear style checklist of required steps and actions needed to successfully respond to specific incident types and threats. So when SOAR detects an incident type, it provides you with the playbook that can help you go through the checklist of it and respond back to the incident. Also, they have the automated conditional steps, which is called Runbook. So a runbook is a series of automated conditional steps that are part of an incident response procedure. A playbook focuses more on manual steps to be performed, and a runbook is usually actions that are performed automatically. So with a playbook, you as the administrator of the SOAR are going to take this steps. But with a runbook, the SOAR itself is going to start initializing the steps needed to be taken because those are automated procedures. Most SOAR platforms have pre-configured out-of-the-box playbooks that are based on industry best practices and recognized standards. Also, they get updated as you move. Like when the new best practices are known and defined, your SOAR receives an update and your playbooks are going to be updated as well. Containment is limiting the spread of the attack and is actually the second logical step after you start the playbooks or runbooks. It can be most effective when the network has been properly designed, especially if you have segmented your network, because now you can contain the attack to that certain segment. A lot of bad designs have many computers connected in just one segment to the network, right? So that if one of them is actually compromised, the lateral movement, the east-west movement within the network is now really easy for the bad actor to conduct. But if you have segments, you have virtual LANs, right? And you have segmentized your LAN into smaller segments for each functionality, or let's say even one functionality is broken into smaller teams and groups. Now, when a segment is contaminated, you can basically contain that specific segment and disconnect it from the network so that you can protect the rest of the networks. Most of the time, these network segments are built based on business units, location, or level of sensitivity of the data, or the security or the impact of the data within that segment. However, remember, it can only restrict attackers by limiting access to the other parts of the network. When an attack occurs, isolation is then used to segregate both the attacker and the infected systems from breaching others. And then you're going to study and sometimes even track back from within the same segment. Now that you know the attacker is in one of these segments and you have isolated the attacker or the attack, now it's time to change the configurations, right? So to neutralize an attacker, you have to limit the spread of the attack and then prevent additional successful incidents. Basically, now that you know the attacker is using such and such protocol, the attack is happening on such and such ports, you may want to go in and change your firewall rules not to allow that specific port anymore, or not to allow IP addresses from that specific location that you know the attack is being coming from, right? So configuration changes may need to be applied into the firewall rules to limit the traffic, to the content or URL filters to limit the content transmission, digital certificates so that you don't let the attacker abuse your PKI or whatever key infrastructure you have. Data loss prevention settings to make sure the attacker cannot steal your information. Like if the attacker is on port 8080, for example, and now you see the download is happening through 8080, you want to immediately close 80 so that the data loss is not happening through that. They cannot download your information out of your network. And then mobile device management settings as well, because now those mobile devices may be contaminated at the same time, or attacker may even have used those. It is ironic to know that most of the time, the first footholds of attackers are the mobile devices, because those are easier to attack on and those are easier to be exploited. So that's why one of the things we want to make sure we're doing, taking action on, is to change the configuration on the mobile devices. Let's do another knowledge activity. What must be incorporated into network design to restrict attackers by limiting access to other parts of the network? And the correct answer is network segmentation. Next step is going to be investigating the attack. So a cybersecurity incident should be fully investigated, because you want to pinpoint how the incident really occurred so that you can mitigate the future incidents. And also you need to document those most of the time for regulatory compliance reporting. Incident investigation involves the analysis of the data sources and performing a digital forensics investigation to be able to really track down what happened during the attack. One of the sources that can really help and analysis of an incident are the log files. Using data from log files involve identifying the log file source, collecting the data, and analyzing the data from that log file. Security logs can really reveal the type of attacks that was directed at the network and how it successfully circumvented existing security defenses so that you can make a decision for how to plan and implement your security defenses in future. Network-based devices, they have logs, and their logs provide beneficial security data for an investigation. You also look into system logs, right? System log files for authentication servers in particular should be investigated so that you can know how that attack happened and how the authentication and authorization were actually be circumvented. You also look into the application log files, which can give information about attacks focused on different applications and learn from that for future so you can either have a better choice of applications with least amount of vulnerabilities, or even make sure you have a good vulnerability and patch management plan in place for certain applications that you use. So vulnerabilities in voice and video communications, especially VoIP, voice over IP, are often compromised to allow attackers to pivot to other resources. And therefore, you also need to look into the logs coming out of the voice over IP systems or any kind of edge communication devices you may have within the network. Problems associated with log management are due to either multiple devices generating the logs and therefore conflicts and overlaps happen, or very large volume of data is being generated as the log that makes the investigation and analysis difficult or sometimes near impossible. And then also there are different log formats generated by different systems, which can also cause issues when you're analyzing the entire system logs. Some of the examples of the logs are listed here, like you have the syslog, which is the system logging protocol, as a standard that is used to send system logs to event messages and that event message servers and then analysis servers. The NX log is a multi-platform log management tool and supports various platforms, log sources, and formats. You also have rsyslog as a solution, which as the abbreviation for Rocket Fast System for Log Processing. This one is an open source. I personally always have a skeptical eye out for open sources, right? It's a utility for forwarding log messages in an IP network on Unix devices. We do have the syslogging, which is an open source utility for Unix devices that include content filtering, and many other tools such as journal control, which is a Linux utility for querying and displaying log files. There are many tools out there that you can use. Actually, there are specific forensics tools that we're going to talk about very soon. No matter what, the final goal here is to understand exactly what happened so that you can plan for the next step, for your next business continuity plan, basically. So usually the output of incident response plan goes and turns into an input to a process that develops and improves the business continuity plan. Data can be accumulated from other sources like the IP monitors that look into the network traffic, the metadata associated with files before and after changes, different analyzers, or even vulnerability scans such as what Tenable, Nessus, or those kind of tools actually provide to an administrator. The last but not the least is the digital forensics. So after the incident happens, your incident response team works and contains the incident and stops the attack, does the analysis, and provides the report. Now it's time for digital forensics to take a deeper look into everything. So forensic science is the application of science to legal questions, right? And forensics can be applied to technology as well, called digital forensics, which uses technology to search for computer evidence of a cyber crime. So whatever is remaining there. Think about the situation that incident happened. The attacker was caught or not. I don't care about that part. But now, looking into a computer as the crime scene, you can actually search for the evidence of the cyber crime. Different computers, mobile devices, cell phones, cameras, virtually any device that has a processor, memory, or storage, even like a Raspberry Pi or Arduino or anything in that realm, can be investigated for digital forensics. So when responding to an incident, there are 5 basic steps that digital forensics follows. First and foremost, secure the crime scene. This is equivalent to the known physical forensics that you are already familiar with, right? All of those yellow tapes around the crime scene. Preserve the evidence. There is a little bit difference here because remember, the evidence you have is a computer device that has volatile memories on it. Like if there is a RAM, if you turn off the computer, information in the RAM is going to be purged and you have no way to return it back. If you don't look for the page files and get them as the computer is on and turn off the computer, then they're not reliable anymore and such. So it's important to preserve the evidence through the knowledge of how a computer system works, where the information can reside on, even the slack, right? As you know, between 2 partitions on a hard drive, you do have a drive slack, which is a space that is not readable by the operating system itself, but this can be used by tools in order to store data or hide information. Think of, I don't know, any kind of cybercrime like child pornography. They can hide the files in that slack, right? And you need to have the knowledge, you need to understand the knowledge and be able to preserve that information, elicit that information, mine it, and then show it and provide it as an evidence, especially in a court of law. Also, establishing a chain of custody. This is important, as you know, a lot of time for a broken chain of custody, the accused can't actually walk because it's impossible to be able to admit a broken chain of custody evidence into the court of law, right? So you have to be careful. Examining the evidence using the forensics tools like FTK, Enscape, and all of those. And finally, enabled recovery. So securing the scene as what individuals in the immediate vicinity should perform, right? That's a part of the damage control. Contact the incident response team. Those need to immediately contact based on your incident response plan. Secure physical security features. Make sure nobody has access to those. Nobody's going into the rooms, to the server rooms and such. Quarantine electronic equipment. If necessary, report the incident to appropriate external authorities. There are some regulatory requirements in place that in case of specific incidents, you have to inform the authorities, and you cannot only let your internal IRP take care of everything. After the response team arrives, the first job is to secure the crime scene, which includes physical surroundings should be documented, photographs should be taken before anything is touched, computer cables should be labeled, so what was connected to what, because these are the mediums that an attacker could have been using. The team takes custody of entire computer along with any peripherals connected to it, and then the team interviews the witnesses. So as you can see, the procedure is very similar to what you already know from non-digital forensics procedures. So preserving the evidence or preservation of the evidence involves ensuring that important proof is not destroyed, so they're staying there. Digital evidence is very fragile, specifically on the volatile storages and memories. Evidence should be placed in bags that have tags or identifying labels. Bags should be sealed to protect the evidence from being altered. A tamper evidence seal is a seal or tape that cannot be removed and reapplied without leaving obvious visual evidence, and those are what we usually use. A tamper-resistant seal is designed to deter tampering with the bag, and there are different type of bags that are available to a digital forensics specialist. Anyway, it's a little bit out of the scope of what we do here. We just want to scratch the surface on the forensics and move forward. If necessary, the judicial system may need to be involved to ensure the integrity of the evidence is maintained and can hold up in a court of law. The admissibility of it is important. So sometimes you just want to call someone from a judge's office to join, or a police officer to join, and all that. You should document chain of custody, documenting the evidence from every step, like from 0 step to last step, should happen, and it's called provenience. Chain of custody documents that the evidence was maintained under strict control at all times, and no unauthorized person was given opportunity to corrupt or tamper with evidence. And it includes documenting all serial numbers of the systems involved, who handled and had custody of the systems and for what length of the time, how computer was shipped, or any other information that can show the entire custody of the evidence. There are specific forms that are being used, and here we do have an example of these forms, right? As you can see, certain information needs to be in here. Every time the evidence is being used, evidence is going to be checked out, used, evaluated, assessed, and then checked back in, so that we can have a very clear track record of how the evidence has been examined. So, of course, after we captured the evidence, we own the evidence, we have the chain of custody set up, it's time to examine for evidence. An order of volatility must be followed when examining evidence in order to preserve the most fragile data first. So you're looking at the most volatile data first, and then you work your way down all the way to the hard drives and those storage spaces, which are involatile. So after a computer forensics expert creates a mirror image of a system, which usually is happening through a cloning tool, the original system is then secured, and then they work on the mirror instead of the real evidence, right? Real computer, right? So mirror images, backup programs rely upon hashing algorithms as part of the validation process. So basically using the hash algorithm, the result should always be the same hash character, right? So if you feed the same data into the same hash algorithm, the result always is going to be the same. So if the data is being tampered with or changed or anything, the hash result is not the same. So integrity of the data is going to be questioned. There are 2 elements frequently overlooked during an investigation. One is the swap file, or the page file that I talked about earlier, and the firmware. They're not looking into these. While the swap file could contain many useful information that was copied into the drive. If you remember, a page file is a memory supporting file on your storage in case the memory, your RAM, is being full and some of the information is not used at the moment, and another application wants to use the RAM space. Basically, it pushes the information that is in the RAM into the drive, which is being saved into the page file. And that can show what was open in the RAM. You can even know what this person actually was looking at before you arrive at their place or before the incident happens, right? And that's where the swap file comes into play. The firmware itself is on a place that has a storage, right? And that storage can be used for hiding information or can reveal a lot of good information about an incident. So hidden clues also can be exposed by examining, like the RAM slack, the drive slack, which is the space between two partitions, or the metadata, which is the information about the information. There is a series of lectures also available about digital forensics. You can look it up if you're interested in the details of the digital forensics. So the next step is enabling the recovery. A final analysis look at recovering the data from the security event, and then lesson learned are going to be documented. So strategic intelligence is the collection, processing, analysis, and dissemination of intelligence for forming policy changes. Through a strategic intelligence, we're going to come up with the new guidelines and policies that can prevent and mitigate such attacks in future. We also have strategic counterintelligence, which involves gaining information about the attacker's intelligence collection capabilities, or getting information about the attacker's location, IP address, where they're coming from, and what they usually do. The process of digital forensics is a very automated process, because manually it's going to take a long time, and most possibly it's going to be impossible to successfully gather evidence. There are software forensics tools that provide this possibility, and some of them are actually having the stamp of NSA or DoD or different different authorities, which makes them even more reliable, because you know that these are the ones that legally have been reviewed, and they are most possibly better, have the better chance in a court of law if you want to provide them. Some of them are listed here, like DD, which sometimes called DNU DD, which is an imaging utility that requires only minimal resources and generates raw image files that can be read by many other programs, like creating a clone. We do have memory dumps in Linux, which as a dumps utility and gets a dump of the system memory. WinHex is there to look into the files and looking into the hexadecimal values and turn them into other values in order to analyze. Autopsy, there's also FTK, there is NCase. There are many forensics tools out there, or toolkits like FTK, that can be used, right? There are also hardware forensic tools that that can work on a digital forensics workstation or a mobile device forensics workstation, and look into the devices, read the information off of the devices that you're trying to gather evidence from, and help you with that. Overall, the idea is you're going to need to have the tools in order to be able to successfully conduct digital forensics investigations. Lastly, we want to talk about the technologies, the new trend, right? Cloud. Everything happens in the cloud these days. And when dealing with a cloud incident, you have to know that initially, before you even start signing a contract, you want to have the right to audit clause included in your agreement with the cloud platform, because otherwise you're not going to have the legal right to review their logs and see what happened in the cloud, right? When a cloud customer is notified by its cloud provider that an incident occurred, the immediate response will be to ask for details about the scope of the impact. The cloud provider may take weeks or months to provide this, but with the clause in the agreement, you can get it faster. The legal, regulatory, or jurisdictional laws that govern the site in which the cloud data resides may present even more difficulties and more hassles for you to look into those. So you're literally at the mercy of the cloud provider, unless you have a very well designed and defined contract with the cloud provider in order to be able to gain access to their logs, audits, and all of those goodies when an incident happens. There are tools to investigate cloud forensics as well, but I want you to remember and note that a cloud platform is at its heart is a large, humongous data center, right? So it's not something out of the Mars. It's just a data center, a lot of computers, a hypervisor, or any kind of virtualization medium, and then you have multiple virtual machines on top. It's a little bit different. Like when you investigate a virtual machine incident, it's a little bit different in technology and the tools needed. It's more like software based in comparison with the physical computer that you have at home. But at the end of the day, all of these virtual machines and hypervisor are residing on a physical infrastructure that provides CPU support, that provides memory support, provides storage support, and all that. So at the end, it all comes back to the same principles when you want to do a direct investigation. And this is what the cloud providers do internally themselves. They do digital forensics internally. They do all the mitigations that were discussed internally on their data center, as you do at your on-prem data center. Let's do a knowledge check activity for the last time in this one. When discussing the chain of custody of evidence in a cybercrime, what does provenance mean? And the correct answer is documenting the evidence from beginning of the investigation. So let's summarize what we reviewed here. Access control is granting or denying approval to use a specific resources. An access control list, or ACL, is a set of permissions that is attached to an object. An incident response plan is a set of written instructions for reacting to a security incident. It is important to test an incident response plan by conducting exercises to make necessary adjustment. If you remember that, tabletop, walkthrough, and simulation. Two elements that are closely associated with using SOARs are a SOAR playbook and a runbook. Following a cybersecurity incident, it must be fully investigated. IP software monitors can provide insight into an incident. Forensics is the application of science to questions that are of interest to the legal profession. Digital forensics uses technology to search for evidence pertaining to a cybercrime or damage that occurred during a cyber incident. As soon as incident response team begins its work, it must start and maintain a strict chain of custody. And finally, there are different software and hardware forensics tools available for analysis.